For decades, astronomers and stargazers alike have speculated, debated, and whispered theories about one of the most enigmatic giants in the night sky. Betelgeuse, the red supergiant star in the constellation Orion, has long stood as one of the most mysterious and fascinating objects ever observed by humanity. For centuries, this colossal star has captivated human imagination with its deep crimson glow, immense scale, and unpredictable behavior that seems almost alive. At roughly 1,400 times the radius of our Sun, Betelgeuse is not just another star in the sky. It is a cosmic titan, a vast furnace of plasma and energy, so enormous that if placed at the center of our solar system, it would engulf the orbit of Jupiter. Over the years, astronomers began noticing something unusual. Betelgeuse was not behaving like a stable supergiant. Its brightness was changing in ways that defied traditional models of stellar physics. It dimmed, brightened, faded again, and then surged unexpectedly, as if something deep within its core was shifting, collapsing, or exploding in cycles. For a time, this behavior sparked intense speculation across the scientific community. Many believed it could be a sign that Betelgeuse was nearing the final stage of its life, potentially preparing for a spectacular supernova explosion. A supernova of this star would not just be an astronomical event. It would be visible in daylight from Earth, casting shadows at night brighter than the full moon. A once-in-a-civilization spectacle of stellar death and rebirth. Telescopes across the world turned toward Orion, collecting continuous streams of data. Scientists built simulations, tested models, and debated possibilities, trying to understand what was unfolding on the surface of this distant giant. The central question remained unanswered. Was Betelgeuse dying, or was it simply undergoing a phase of instability never before observed in such massive stars? The light curve told a confusing story. Instead of a steady decline expected from a dying star, Betelgeuse showed irregular pulsations, as if it were breathing or convulsing in slow motion across astronomical timescales. Theories multiplied. Some suggested massive dust clouds temporarily obscuring the star. Others proposed violent convection currents rising from deep within its interior layers. A few even hinted at unknown stellar mechanisms still not included in modern astrophysics. Then came a turning point. The James Webb Space Telescope was directed toward Betelgeuse, bringing its advanced infrared vision to one of the most debated objects in modern astronomy. With its massive gold-coated mirror and extraordinary sensitivity to faint infrared light, it was capable of revealing structures hidden beneath layers of dust and stellar turbulence. Betelgeuse became a priority target. Scientists hoped that this instrument might finally uncover what was happening beneath the star's chaotic surface. When the first images arrived, they did not bring simplicity. They brought revelation. Betelgeuse appeared not as a dying, fading object, but as a violently active sphere of energy, constantly shifting, boiling, and erupting. Its surface resembled a raging ocean of plasma. Enormous bright regions appeared and disappeared, driven by powerful internal energy flows rising from deep within the star. These were not minor fluctuations. Entire hemispheres of the star seemed to change brightness over short periods, suggesting massive convective structures moving at scales never observed before. Around the star, enormous clouds of gas and dust were discovered, ejected through powerful stellar winds and repeated surface eruptions. These outflows formed vast expanding shells of material, stretching into space and interacting with the surrounding interstellar medium. The result was a complex and dynamic environment, where matter was constantly being expelled, reshaped, and redistributed across light years of space. Betelgeuse was no longer seen as a passive star approaching death. It was a system in violent transition, actively reshaping its surroundings with every eruption. Scientists realized that the final stages of such massive stars may not be slow and predictable. Instead, they may be chaotic, unstable, and full of violent energy releases. This changed long-standing assumptions about how supergiant stars evolve before collapse. Instead of a calm decline into supernova, Betelgeuse suggested a turbulent and unpredictable final act, filled with mass ejections and internal instability. Each eruption observed by the telescope represented a fundamental process of stellar physics, where nuclear fusion, gravity, and radiation pressure interact in extreme conditions. These processes are responsible for creating and distributing the very elements that make up planets, oceans, and even life itself. Iron, carbon, oxygen, calcium, all forged in the hearts of ancient stars, are released into space during such violent endings. In this sense, Betelgeuse is not only a dying star. It is also a source of creation, preparing the raw material for future worlds. The telescope also revealed turbulence on the star's surface, where hot plasma rises and cooler material sinks in vast convection cells. These enormous circulating patterns may explain the irregular brightness changes that have puzzled astronomers for decades. But they also raise deeper questions. Are these processes fully understood, or are we witnessing new forms of stellar behavior that challenge current physics? Beyond the star itself, the surrounding environment tells another story. Expelled material collides with interstellar gas, creating shock waves that ripple outward across space. These shock fronts compress surrounding matter, sometimes triggering the formation of entirely new stars in nearby regions. In this way, the death throes of a massive star can become the birthplace of new stellar systems. This cycle of destruction and creation is one of the fundamental rhythms of the universe. Betelgeuse, in its instability, becomes a powerful example of how cosmic death is never truly an end, but part of a continuous transformation. For astronomers, the possibility of an imminent supernova remains both exciting and uncertain. If Betelgeuse were to explode in our lifetime, it would become one of the most studied cosmic events in human history. The explosion would release energy beyond imagination, briefly outshining entire galaxies and flooding space with radiation and expanding debris. Telescopes would observe the formation of heavy elements in real time, witnessing the creation of materials essential for planets and biological systems. These observations would provide unprecedented insight into how the universe builds complexity from simple hydrogen and helium. But even without an explosion, Betelgeuse continues to teach scientists something profound. The universe is not static. It is dynamic, evolving, and often unpredictable. Each new observation reveals deeper layers of complexity hidden within what once seemed like familiar celestial objects. Stars are not simple spheres of burning gas. They are living systems governed by competing forces, constantly changing over time. Betelgeuse, in particular, has become a symbol of this complexity. A reminder that even the most studied objects in the sky can still hold surprises. As observations continue, scientists refine their models, adjusting theories to match the extraordinary data being received. The telescope's vision continues to expand our understanding, revealing that the universe is far more active and intricate than previously believed. Each photon collected from Betelgeuse has traveled across unimaginable distances, carrying with it information from a distant and violent stellar environment. And when these photons finally reach human instruments, they transform into knowledge, reshaping our understanding of existence itself. Betelgeuse stands not only as a star nearing its final stages, but as a cosmic teacher, revealing the hidden mechanics of stellar life and death. It reminds us that the universe is filled with processes far beyond human intuition, operating on scales of energy and time that defy everyday experience. And as long as we continue to observe, there will always be more to discover, more to question, and more to understand about the vast cosmic story unfolding above us.